Hello all and welcome to my YouTube channel. Welcome to this series of LangGraph. So we have already covered the basics of LangGraph in our previous videos. So if you have missed that, please go ahead and check out that. The link is available in the description below. Now today we are going to solve an real-time use case from automobile sector. So we will be building in multi-agent solutions in order to detect whether the claim that the users are submitting or the claim that the customers are submitting are valid or not, and based on that we will be approving the claim, rejecting it, or raising it for the human approval. Now, so the automobile organization is facing a challenge where whenever the customer is submitting any claim against any accident or against any damage happened to the car, what happens is that currently the process is manual, where the organization need to manually review the claim, compare it with the standard policy that is available with them, and accordingly they need to take a decision whether they can approve the claim or not. And there are high chances of human error in such cases because the humans are manually involved and comparing the documents. Again, it is a mundane task where user always feels boring in order to compare the documents, and that's where we are trying to automate the process. So we have built in multi-agent solutions where each agent is going to act as an expert in the respective area and going to validate this claim that is submitted by the customer against the standard policy available for the organization. So without wasting time, let's test the application first. So as you can see, we have an option available for users to browse the files. So user can click on browse, and let me select the claim first. Okay, you can see this is the preview of claim where we have an claim ID, model of that particular vehicle. So it's Volt X four-wheeler electric vehicle sedan. Then the purchase date is from August 2024 and the claim date is on May 2025. Then we have dates since purchase, the age of vehicle in days. Then we have the total mileage cover, the part that is replaced. So this is the headlight, the part cost in dollar 231, the labor cost, and the total cost, and whether the invoice is present, whether the damage vehicle image is present or not, and is there any previous claim for the same vehicle. So yes, one meaning there is one previous claim, and here one meaning the image is present, zero meaning the image is absent. Now this information we have obtained it from the garage wherever the vehicle has been repaired. So based on that particular invoice and this particular data, we are going to compare it with our standard policy that is available for the organization, and then it will generate the final result. Now, this information we can easily get in the form of structured data, like in the form of CSV or tables, because this information, right, the garages are putting this information into their system, and from the system it is very simple to extract these information in the CSV. So this is the unstructured data that this is the structured data that we have, and unstructured data is our standard policy. I will show you that policy as well. So first of all, let's go ahead and click on generate results. Now as soon as we have hit the generate result, you can see it is analyzing the claim, and now what it will happen is it will compare this particular submitted claim against the standard policy available for the organization for this particular model, and then it will generate the final results. Okay, you can see the processing has been complete. So let's go ahead and see. Okay, in the summary we have uploaded total one document. Out of that, 0 is approved, 1 that was submitted is rejected and escalated. So this is how we are showcasing the final result. And you can see under the detailed results we have this option available where we can go ahead and see whatever results that it has generated. So you can see how beautifully it is doing the comparison. Okay, you can see reason. So first agent we have is the policy check agent, which is generating the result. Okay, the replaced part is headlight, which is not listed under the covered parts of four-wheeler in the warranty policy. Meaning under the standard warranty policy, the headlight is not covered. That's where it is rejecting that particular thing. And that's where it is rejecting the claim. Then we have fraud score agent, which is generating the fraud score. Now user or the customer who has submitted the claim, right, they might not be aware whether headlight is covered or not as per the standard policy. So fraud score is zero point 0.2 only, which is between 0 to 1, meaning user is not trying to fraud anything, or customer is not trying to submit the fraud claim. Customer is just checking whether headlight is covered or not, right? That's where fraud score is minimum. Then we have claim evidence agent, which is generating the complete evidence, which does the thorough analysis. And as you can see, it is saying that, okay, claim review, this is the claim model that is the review for, then comparison against policy. Okay, you can see it is saying that, okay, documentation requirements, invoice present, image present. Then you can see service card you can see it is not mentioned, but not explicitly required for this particular claim, then conclusion documentations are met. So we don't have any issues from the documentation perspective. Then warranty coverage, it is giving that, okay, vehicle is four-wheeler, warranty period is 365 days or 20 kilometer, whichever comes first. And for this vehicle, it is purchased 289 days, which is within the limit. Mileage is 7.3K kilometer, which is again within the limit of 20,000 kilometer. Conclusion, warranty coverage is also valid. Then it is checking other details like, okay, covered parts, part replaces headlight. Four-wheeler covered parts are these many from the standard policy: brake pad, airbag, fuel pump, battery, and the sensory elements. And the conclusion, headlight is not covered for the four-wheeler parts. So, okay, you can see then the total labor cost, it is checking whether the labor cost is within the range or not. And then again, total final conclusion it is giving. Then it is checking the fraud indicators. The fraud score is zero point 0.2 and all other information that it has checked. Then it has checked invoice VIN. VIN is vehicle identification number. So invoice is present and no mismatch in vehicle identification number reported. So conclusion, no fraud indicators are triggered as of now. Then it is checking this escalation rules. Then, okay, no need to escalate. Red flags. What are the red flags or violation? Is this only. Part replaced is headlight, which is not covered, right? And as the part is not covered, that's where it is sending this particular final assessment to the decision agent, and then decision agent has rejected the claim. So that's how the overall workflow happened. You can see the multiple agents who have, and these agents are expert in their area. The policy check agent is only comparing the policy at high level, extracting the policy details, and then fraud score is generating the final score. Evidence agent is comparing each and everything that is submitted by the user against the policy standard document, right? And then the decision agent is taking the final decision whether to approve it, reject it, or escalate it for the human approval. Okay, so we can download the CSV from here. So that way we can extract the information, extract the results. Now, we have also added few details here. You can see from here, you can select the row that we have uploaded. So currently there is only one row. And here we are showcasing the complete workflow, meaning what and all conversation that have happened across multiple agents, we have captured that tracing here so that you will get an idea how exactly the conversation happened, how the agents are handling the responses smartly. And if you think that, okay, there is some repetitions across the agent, or if some agent is failing, you can quickly go ahead and fix that. That's what this tracing is going to help. So let's see, you can see in the policy check, you can see this is the policy manual that it has read. And again, it's a synthetic data that I have generated. So you can see it is giving all the information for warranty coverage, cover parts, all that standard document that it has extracted. And this is in the form of PDF that it has read and extracted the information. And then it has generated the response. Okay, the headlight is not covered. Then fraud scoring agent consumed this particular information, and accordingly it has generated the response as 0.2. Then evidence collector agent, as you can see, it has consumed the information and then it has generated this particular claim. That's what we have seen already, right? And the action agent, okay, based on this, you can see now the action agent will take a decision. So all that information, you can see the response is the replaced part headlight is not listed as covered part for four-wheeler under the warranty policy, making the claim ineligible for the coverage despite meeting other criteria. Meaning this decision agent is doing the thorough analysis and then taking a decision, because see, we want a high level accuracy in this particular part. If unnecessarily, if you are rejecting the claim for user, right, then or the customer, right, it will be hectic for customer and you may lose the customer. And in order to avoid that, that's where we have built this multi-agent system, because these scenarios may get complex as soon as you integrate more and more details into your policy. As soon as you add more, or your claim is more complicated, it will add complexity into your workflow. That's where we have a individual agent to handle the individual scenario. Okay, let's go ahead and upload the new data. So let's click on browse file, and so let me clean this. Let's go ahead and select the claims. Now, okay, we are selecting these 4 claims, you can see. And let's see how exactly it is generating the results. Let's click on generate results. Okay, you can see it is analyzing the claims. And as we have built this multi-agent system, right, we have given the feasibility where you can upload multiple files as well. Currently, you can see it is taking a lot of time in order to process the document. You can see it has processed one document out of four because we haven't enabled the parallel processing. You can enable the parallel processing, and it is very much simple in the graph. We will be covering that in the upcoming videos. Then we will see how exactly these four rows that we have submitted, we can execute them parallelly and we can improve the performance as well. So okay, you can see it has processed 3 files out of 4. Okay, you can see the processing has been completed. You can see the total documents we submitted, one out of which one is approved, two rejected, and one is escalated for manual review. And you can go ahead and check the complete details, why it is rejected, what and all details. You can see the fraud score is very high for some of the cases. That's where it has escalated it for the human approval. All those information it has given and the final decision. And then again, you can see below the tracing of agents. From here, you can select for which row you want to trace it. Let's say if you want to trace it for row 1, you can go ahead and trace it all the information. You can see it is not covered by the policy. All that information it is capturing. So yeah, I hope you are interested in building this particular project. So please stay till the end of this particular video where we will go ahead and build this end-to-end solution, and you will be able to understand how exactly the multi-agent framework you can build with the help of LangGraph. So yeah, let's go ahead and see the architecture for this particular project first. Okay, so this is the architecture that we have built. So you can see where user have the feasibility to upload the CSV. So once the CSV is uploaded, so basically out of that CSV we'll be understanding what is the claim information that the user have submitted or the customer have submitted. And this particular application is built on Streamlit currently. The user interface is built on Streamlit. And now you can see then we have a standard policy document which is in the format of PDF. And this PDF again is a unstructured data. So this is our structured data. Now this structured data and the unstructured data, we are passing it to the agents. And these are the 4 agents that we have built. First one is the policy checker, then fraud scoring agent, the evidence collector agent, and the action agent, which is generating the final response. So whenever this particular claim is submitted, these agents will collaborate with each other. They will understand the standard policy, compare the structure that compare the claim submitted by the customer with the standard policy, and it will generate these final output, which will take a decision, which will generate the fraud score and generate the final evidence report. And that evidence report again it will go and showcase on the UI. Now we have used Azure OpenAI in order to enable the large language model capability for our agent, and here we have used GPT-4o model. And as I mentioned, this complete framework is built on LangGraph. So we will be seeing how exactly these agents are getting called one after the another in order to solve this particular use case. So, okay, the architecture is very simple. I hope it is clear to you. So if you have any questions related to this, please ping me down in the comment section. Now it's time to get started with our coding exercise. So again, in the coding exercise, we'll be seeing how exactly we can build this particular end-to-end solution. So see you soon in the coding session. Okay, so I have opened my Visual Studio Code. We'll be using an UV Python package manager in order to set up a project structure. So let's go ahead and open the terminal. And first of all, let's go ahead and install the UV. Pip install UV, simple command. So for me, I have already installed that. If you haven't, go ahead and install that. And then let's go ahead and create the virtual environment first. UV VNV .venv. So .venv is the name of virtual environment. Let's hit enter. Okay, you can see it has created the .venv for us. And in order to activate that, we need to execute this particular activate file. So the file is there in venv currently under scripts. Then we have activate. Okay, you can see the venv has been activated. Let me go ahead and add the requirements file quickly. Okay, see these are the requirements that we will be using. Let's go ahead and install the requirements. UV pip install -r requirements.txt. Okay, it will go ahead and install the dependencies quickly. Meanwhile, let's go ahead and create the env file. Then also we will be requiring a one file where we will test our code. So let's create the Jupyter file first. I have created agent.ipynb file. Okay, you can see all the dependencies have been installed. So let's start writing our code now. Okay, So first of all, let's go ahead and select the kernel. So click on Python, and this is the VNV that we have created. So let's select this virtual environment. As we have installed the dependencies, we no need to install it again. So first of all, let me go ahead and import the dependencies that we'll be using. We'll be using pandas in order to read the CSV file. Then we have LangGraph.graph in order to create the basic graph structure. LangChain OpenAI we have in order to load the large language model from Azure OpenAI. Then we have document loader in order to parse the PDF that we will be uploading, and then load.env in order to read the secrets. Okay. So okay, it is asking us to install the IPyY kernel. So first of all, let's go ahead and install that. So if you are creating the Jupyter notebook first time in your VS Code, it will ask you to install the IPyY kernel. Okay, now let's go ahead and read the data that we have added. So before that, first of all, let me go ahead and add the data. So let me create a folder data, and under that data, let me paste the information. Okay, so as you can see, I have added these information. So let me show you how exactly the data looks like. So this is the standard policy document that is available, which is again a synthetic data that I have created, where you can see we have a document requirementation, then warranty coverage, covered parts, labor and cost guidance, fraud indicators, escalation rules. That information we have added in the standard policy document. So whenever user is whenever customer is submitting any claim, it will be compared against this particular standard policy document. And then this warranty claim that we have already seen, where we have these car information, the model information, and the other information that is captured from the garage. Okay, so okay, you can see it is saying false because we haven't added any environment configurations. So first of all, we need to add the environment configuration. So let me go ahead and add that. Okay, so we'll be using Azure OpenAI as I mentioned. So I have added my information. Let me show you from where we have grabbed that particular information. So go to portal.azure.com, from where you need to create an Azure OpenAI service. Okay, so this is the service that I have created, policy project. So as you can see, this Azure OpenAI, you need to select this particular service and you need to create new service. You need to fill the resource group information, pricing tier you need to select, and once you click next, and it will create one service for you. So once the service is created, it will look something like this. Then you can click on that service, and from that service you can go to the Azure Foundry portal. If you are new to this, please go ahead and explore my YouTube channel. I have already covered this particular step multiple times. So let's click on Azure AI Foundry portal. Now this is the AI Foundry portal where all the AI related services are accumulated. Again, so if you are new to this, please go ahead and explore my YouTube channel. I have already covered all those details in depth. And in the models and deployment sections, I have already deployed a GPT-4 model. So you can see this is the model that I have deployed. In order to deploy the model, you can select the base model here. And from there, you can select the model that you want to deploy. So let's say if you want to deploy GPT 4.1, you can click on that and you can click confirm and you can select the configurations and deploy the model. So it is that easy. So I'll not go ahead and do that because I already have this. And the key and endpoint information, I have captured it from this particular GPT-4 model. So you can see this is the key that I have copied and this is the endpoint that I have copied. So if you can see, that's the endpoint and the key information that I have given. I'll be deleting this particular key before uploading the video, but make sure you are not exposing your secrets. Okay, let's continue with our development. Now it's time to load the data. Okay, so as you can see, claims DF will be reading the warranty claims CSV from the data. Then from the langchain.document loaders, we no need to add it here because we already imported that. We'll be using this PyPDF loader, and that will load the CSV and which will extract the information, the policy text. So let's go ahead and execute this. Let me show you the claims data that we have. Let me close the terminal. You can see this is the claim information that we have with us that we have already seen. Now let me show you the policy text information. You can see Auto Drive Motors Private Limited. This is the information, right? Document requires every warranty claim. Whatever PDF that we have seen, we have extracted the text out of that particular PDF. Now the next step is we need to load the large language model. To load the large language model, we can go ahead and use this code. So we'll be using Azure OpenAI class, which is available in the LangGraph, which is available in the LangChain. And then we'll be using the Azure OpenAI API key the API version, the OpenAPI endpoint, the model name, and the temperature we have set. These two information we have already saved it into the environment file, as you can see here. So from here, we have imported those two environment configurations and we have built the LLM object. Okay, it is saying that missing credentials because we haven't executed this sale again post uploading the environment. So let's go ahead and execute this. Now you can see it has changed to true. And now let's go ahead and execute this. Okay, so the model has been imported successfully in the LLM object. Now next is we need to define the state. Now defining graph state is very much important because this is going to pass the messages from one agent to another agent. So as you can see, we have first claim, whatever claim submitted by the user, which is in the format of dictionary. So this particular data that we have will be converted into dictionary. A key value pair, claim ID is going to be the key and the value is going to be the value inside that key. Then policy check, again it's going to be the string. Fraud score we are generating in float. Evidence again is a string and decision is again a string. That is what we have mentioned, because if you see on our project, so if you see this information, whatever we are passing, right, for policy agent it is in the format of string. For fraud agent, it is generating the response in the format of float. Then evidence agent again in string format. So that information we have captured here. So this maintains the state of memory which we are or the state of memory which is flowing from one agent to another agent. So that's the thing that we need to define. Now the next part is building an agent. So first of all, let's go ahead and build the policy agent. So again, building an agent is very simple. We can write a simple Python function, and that Python function, we just need to pass the state of the object, whatever state object that we have created. And in that we need to pass a state. So state, we have already defined it as claim state. We can see from claim state, it is going to extract the claim. So out of this, it will extract the claim. And then it is checking the type of model, whether it is four-wheeler or two-wheeler. Based on that, it will check the policy. And then you can see it is, we have passed the policy text that we have extracted. It is selecting the vehicle type and the claim detail, and based on the warranty days, mileage and covered parts, is this claim under the policy or not, that answer it is generating. And this information, prompt information, it is passing to the LLM. We are using llm.invoke, we are passing the prompt, and this LLM is generating the response. And then we are stripping the response at the end. So, and that is going to return the state. Now the state is nothing but the policy check. As you can see, first policy check is going to return this policy check as an output, which is in the format of state. So if you are not aware about the state, I have already covered that in the basics. So please go ahead and check out that. Now, this is the simple function that we have written. Let's go ahead and build the fraudulent agent. Again, fraud agent is similar to this only. So you can see we have written a Python function, same thing, where we have generated the prompt and we have given a customized prompt for this particular fraud agent. And then it is taking a decision, it is generating the final score. You can see, but final score it is generating based on the LLM. It is passing this information, whatever is extracted based on the claim that the customer has submitted, and then it will generate a number between 0 and 1 based on the fraud, likelihood of the fraud. The next one we have is the evidence agent. So let's go ahead and build the evidence agent. Now for evidence agent, again, you can see we have written the same function and we have given the prompt. And the task of this is to compare claim against the policy manual and list the red flags or violation found. If none, say no issues. And that is what it is returning. And it is returning the state of evidence. Meaning in the claim state, now we have claim information, we have policy check information, fraud score, evidence score. Now only the thing that is pending is the decision. So we'll be adding a decision. Now for decision, we have an action agent. Now the action agent is a bit different. So, okay, you can see for the action agent, as it is taking the final decision, we have added the state information. Then we are in extracting all the previous information that have happened, and then we have given a prompt. So you can see it is a warranty checker, which based on the given information, it is generating whether we can approve the claim or not. So that information we have given all the information that we have extracted from the previous agent, and then it is taking the decision. And in order to take the decision, we have written custom functions. So you can see first we are invoking the response from the LLM, and based on that response, if approve is there, we are going and taking a decision of approve. If reject is there, we are rejecting it. If escalate is there, then we are escalating it to the human in the loop interval. Human in the loop. HITL is nothing but human in the loop. And then if there is exception, then it is generating all that custom thing. So this is the custom thing that we have written. Again, it is checking whether fraud score is greater than 0.5 or not. So that information it is keeping. Now let's go ahead and execute this. Okay, so this Python functions we have defined. Now it's time to go ahead and build the graph structure. So let's see how exactly we can go ahead and build the graph structure. Now, in order to build the graph structure, it is again very simple. You can see we have created a basic graph state, which is a with the help of state graph. Now, state graph is a class available in LangGraph, which help us build the basic graph structure. And for that, we have passed our custom memory state. And then you can see we have graph.add node. First, we have added a policy checker node, then fraudulent scoring, evidence collector, and action. And against that, we have given the Python functions that we have generated. Simple thing. And then we are setting entry point for the graph, which is policy check. Then we are adding age between policy check to fraud score, then fraud score to evidence collector to action, and then action to end. So we are starting the conversation with policy check, ending it with the end node. And then we are compiling the graph. Very simple. Let's go ahead and execute this. Now let's go ahead and visualize how exactly this graph looks like. Okay, so we'll be using a draw mermaid in order to see what is the structure that it has built. So let's execute this. This is the graph structure that it has built. Now, in order to visualize the graph, you can copy this particular metadata that it has given. And then you can go to mermaid.live. So if you go to mermaid.live, and from here, you just need to remove this particular code and you need to paste that. So whatever we have created. Okay, so you can see we are starting the conversation, then we have policy check agent, fraud scoring agent, evidence collector agent, action agent, and then we are ending the conversation. So this is what we have built as a graph structure. Each individual node is acting as an individual agent. So that's how we have built the multi-agent framework. Now let's go ahead and test this, whether it is working or not. Again, so for testing, we'll be using simple code. So you can see, so first of all, from the claims DF, we'll be iterating row by row, and then we'll be invoking the app that we have built. If you see here, we have built this particular app, and with the help of that app, we are going to append these particular results. So first of all, we'll be calculating the state. Now the state is nothing but our final response that it has generated. And what is going to be the response is this. That state will have claim, then it will have policy check, then it will have fraud score, evidence, and decision. All that information it will have. So that's the final memory that is generated, final result. And then this code is in order to save the results. But let me hide this. We no need to save the results. Let's go ahead and execute this. Now you can see it is iterating the row by row. There is currently only single row available. So it will go ahead and invoke and generate the result for that. Now in the app, it will go ahead and start the conversation with policy checker first, then it will calculate the fraud score, then it will collect the evidence, and it will generate the final action. Okay, you can see it has generated. Now let's go ahead and see what is there in the result DF. Okay, so you can see in the result DF, we have all that particular information, like for this particular claim ID, this model and decision, we have this policy check, fraud score, evidence. That information is available. We cannot visualize the complete data frame here, but that's fine. Let's see what's there in the state. So in the state, you will find all that information. You can see claim is the dictionary where we have given all the information of the claim submitted by the user. You can see we have claim ID, model, purchase date, all that information. Then we have policy check, which is in the format of string, which is giving the final response generated by the policy check agent. Fraud score, which was float, so it has generated the float response. Evidence, again it is string, it has generated the string response. And decision, final decision, it is saying escalate to human in the loop. So that's how the graph is working. Now as we have tested this particular graph and it's working, what we need to do is we just need to build the modules around this in order to build the final project. So what I'll be doing is I'll be converting this particular IPYNB file into main.py, where I'll copy paste this particular code, and then we'll build an UI with the help of Streamlit. So let's go ahead and create a main.py. Okay, so let's copy the same information. So from agent.py, we can go ahead and copy this import statement first of all. So let's add that. Now after this, I have done some changes. So let me add that. Let's define the state that we have already defined. You can see claim state that we have defined. Then next part is we need to load the PDF. So for that, I have changed the code little bit. So let me go ahead and add that. So I've just written one simple code in order to read the policy. So you can see from the LangChain document loader, we are reading this particular file, auto warranty policy. Then with the help of PyPDF loader, we have loaded the CSV, and from that we have extracted the text. And if the text is not available, then we are just then we are passing it to the exception, and we are just adding the policy text. So that's the simple code that we have written in order to load the policy document. Now the next step is to add the LLM. Again, same thing. We can go ahead and copy paste this particular part of loading the LLM, and we can add that into main.py. Let's insert that part here. So again, it will read the information from .env, and that's how we have created LLM object. Now the next step is go ahead and copy all the policy agents that we have generated. Okay, so simple thing, I'm just pasting all the 4 policy agents that we have created. So okay, you can see first one is the policy check agent that we have added. Same thing that we have just copy pasted. Second, fraud agent, fraud scoring agent that we have added. Again, you can see the prompt and all that information. Evidence collector, same evidence collector we have added here. Then action agent, which is generating the final action. Same action agent we have added in this particular part. Now the next step is, now as in the IPYNB file, we are manually running this particular workflow in order to generate this particular response. Now this part, let me write it in the proper function so that we can modularize it and we can call it in the app.py file that we will be building the UI file. So in order to add that, I have written a simple function, process claim. You can see this is the process claim function that I have added. Now this process claim, what exactly it is going to do is it is going to process the claim and return the flattened data frame. So the input to this is nothing but the claims as a data frame, each row as a claim, and then it is going to generate the final, response by invoking the policy check, fraud score, evidence, and decision agent. So if you see here, it has extracted the state information, and then for each one, it has passed this particular state. Currently in the state, we have the metadata, that is the customer have submitted the claim information. That claim it is passing to policy checker, which is going to generate the final state with the user input as well as with the policy output, policy check agent output. That output it will pass to next agent. That's how we have built this particular agent. Simple thing. And then we have just flattened that particular response and generated the or written the final data frame. So it is that simple. Okay, so these two things are not there. Let me go ahead and import those two things. So from typing, we can import that. Okay. So you can see the error is no longer available now. So this is done. Now the next step is we can go ahead and generate the app.py. So in the app.py, we are going to write our actual Streamlit code. So let me go ahead and copy that particular code in order to save the time. Okay, so you can see we have used Streamlit, that pandas, in order to read the file, and from main we are importing the process claim. So from this particular main file, whatever is there, this particular process claim will just invoking this particular claim, and then it will one by one call these individual agents and generate the final response. Okay, then this is the information that we have added in order to generate our UI. You can see this is the title that we have said, HITL Warranty Fraud Detector. HITL is our YouTube channel. So if you haven't subscribed to that, please go ahead and subscribe to my YouTube channel. Then we have a markdown in order to add the color coding and styling. So it's that particular information. So you can go ahead and this is not a Streamlit class, so I'm going to exclude this particular part. Again, it is very simple. Streamlit is one of the simplest platform that is available in order to build your quick UI. So that's fine. And then we have added the buttons and all that information. We have added a upload CSV option, then the action option, the generate results button that we have added. And based on that, from those results, you can see we are calling the process claim here. If you see, so this is all the UI part. And the actual thing, you can see once the user uploaded the CSV, it will read that particular CSV, it will convert that into data frame, and then if you see process claim, once we hit the submit, you can see the spinner runs, and then in the process claim, we are uploading this particular uploaded DF, and then it is going to generate the final result. So this results, then we are going ahead and showcasing it on the UI, and then we have added these cards, right? The total claims that we have submitted, then we are showcasing the approved one, rejected one, and the escalated one. All that information we are showcasing, and again the color styling for that particular cards that we have added, and the other information where we are tracing. So if you see, we have added the traces as well. So that information we have showcased here. Now, one change is there in the main.py. In order to trace the logs, what I have done is I have added the tracing in the state. So let me show you that quickly. So if you see in the main.py, I have added this particular trace as part of list, meaning whatever conversation that is happening for each row, we are going to collect that as a list, and that list we are passing, so that this particular part that we have built, this part, we can show how exactly the conversation have happened across these agents. So in order to showcase this part, we have passed this trace. So that it is the trace that we have added. And then we are just showcasing that particular trace. Whenever user is selecting the individual row, it is showcasing the complete trace that is available. So that's the simple UI that we have built. So all our project is ready now. Let's go ahead and quickly run the application. So in order to run that, let me go ahead and open the terminal. So we should be in VNV. We should be in virtual environment, you can see. And then the command to start the application is Streamlit run app.py. So let's go ahead and execute this particular file. I hope it should run. Okay, you can see the Streamlit app is running. Okay, you can see we are able to successfully load the application, and we have this browse option available. So let's click on browse. Let's select the warranty claims. Okay, you can see the preview is available, claim ID, all the information that we have seen earlier. Let's go ahead and generate the result. Okay, you can see analyzing the claim, and here you can see the application is started at the localhost, this particular address, and currently it is processing the claims. Okay, you can see the claim summary has been generated. Total document we have uploaded 1, out of which 0 approved, 0 rejected, and 1 is escalated. And this is the final response that we can see. It is generating these reasonings, generating the evidence, and all that information. And the final, from here you can go ahead and download the CSV. And if you open that particular CSV, you will see that all the information that it has captured. So all the model information, then to the right, you have this escalation, why it is as escalated. You can see the agent information. Everything is available in the CSV that you can use. And also you can trace the application logs here, how the conversation have happened across the different agent. That tracing is also available here. Okay, you can see it has given that particular information, and the app is running successfully. So yeah, I know I have not covered the Streamlit part in depth, but yeah, if you are interested and if you want me to cover the Streamlit part as well, please let me know in the comment section. But the Streamlit code is very simple. If you just read through this particular code, you will be able to understand that. So I'll be attaching the data as well as the whole code into my GitHub. So please find the link in the comment section below. From there, you can go ahead and check out that. So please feel free to try it out, this particular project. So it will be a very good hands-on for you as well. And if you are facing any issues, please let me know in the comment section below. So yeah, I hope this was helpful for you. And with the help of this particular thing, you will be able to build an end-to-end multi-agent solutions with the help of LangGraph. Now, this was the very simple use case that we have covered, but which is a real-time use case. Now, you can expand this use case by attaching and more your custom data. You can try it on your custom information, a custom data set that you have. Okay, so if you like this particular video, please like the video, subscribe to my YouTube channel, and share it with your friends. And if you want me to cover such more beautiful projects, please let me know in the comment sections. So thank you so much, and I'll see you soon in the next interesting video. Thank you.